8% of Earth's crust is aluminum. Aluminum is obtained from ores, particularly from bauxite, one that is mainly composed of aluminum oxide. Say you have a kilogram of the ore that is purely aluminum oxide, how much aluminum can be extracted from it? This question is still rooted from our understanding of molar mass. We simply need to take the math a little further to make it more useful in our analysis. Let us create an analogy first of what we would like to do here. For example, you made a deal with your friend that for every 50 earned in his business, you get 20 as an investor. Stating it that way, 20 in every 50, that is a very lousy math. Prehistoric people in the riversides of Mesopotamia knew better math than that. No one makes a contract like that. You say instead 40% of the earnings, not 20 and 50. To get the percentage of something, you divide the part by the total and multiply it by 100. 20 divided by 50 and multiplied by 100 gives 40%. So let us jump right into that problem of extracting aluminum from aluminum oxide. So the situation is, what mass of aluminum can you obtain from 1 kilogram of bauxite? If we only knew what percentage of aluminum is there in a bauxite, then it is a quick work. What we know is there are 2 aluminum atoms in it for every 3 oxygen atoms. And each aluminum atom is 27 grams per mole, and twice that is 54 grams per mole. Each oxygen atom is 16 grams per mole, and thrice that is 48 grams per mole. Therefore, aluminum oxide is 102 grams per mole. To state it crudely, 54 in that 102 is aluminum. That is 52.9%. You have 1 kilogram multiplied by 52.9 divided by 100, you get 0.529 kilograms or 529 grams. More than half of the mass of the bauxite is aluminum. The remaining 47.1% must be composed of oxygen atoms. An iPhone 10 contains around 40 grams of aluminum. So a kilogram of that rock can provide enough aluminum metals for a dozen iPhones. You wonder why it is so expensive. This is an illustration of the concept called percent composition of compounds. It expresses the mass of each component element per 100 mass units of the compound. The percent composition of an element in a compound is the mass of the element divided by the mass of the compound multiplied by 100. You may take note of this as this formula shown. Substances with different percent compositions are used every day. Percent composition allows you to know the ideal dosage or amount of substances to use. Cane vinegar contains 4.5% acetic acid. A normal saline solution for intravenous injection for fluid and electrolyte replenishment contains 0.9% sodium chloride. Your ordinary Portland cement becomes ideal for underwater construction if it is 1% to 3% aluminum sulfate, because in that proportion it will harden fast. There it is. Science continues to advance our knowledge. Maybe it begins with something so banal as doing these rudiments. Percentage, that's basic math. Probably tomorrow you have the answer our society needs. For now, let's see if you are preparing well for it.